All right, let's dive into the world of unmanned aerial systems. In this explainer, we're going to break down what they are, see how they've evolved, and get into the nitty-gritty of the systems that make them one of the most powerful tools out there today. Let's get right to it.
Just think about that for a second. A flying machine, airborne for months, doing incredibly complex jobs with no pilot inside. Sounds like something out of a sci-fi movie, right? Well, it's not. That's the modern unmanned aerial vehicle, or UAV. Today, we're going to unpack just how these silent eyes in the sky became the incredible pieces of technology they are.
So, here's our flight plan. We'll kick things off with their origins. Then we'll look at what they actually do and the gear they carry. After that, we'll break down the whole system, see how they're used out in the field, touch on some advanced sensors, and then we'll wrap it all up with a quick recap and a final question for you.
Okay, first up, introduction and genesis. This is where we trace the family tree, from the simplest little drones all the way to the super complex autonomous systems we see operating today.
So, at its most basic, a UAV is just an unmanned flying platform. It's got sensors on board and it flies a path that's either pre-programmed or controlled by someone on the ground. But here's what makes them so incredibly effective. They're stealth. They're small, they have a tiny radar signature, and they give off very little heat, which makes them a real ghost on the battlefield. Just incredibly tough to spot.
The whole journey really starts with the drone, and we're talking about the most basic version here. It's small, you have to be able to see it to fly it, and its battery life is, well, it's not great. Think of this as the simple, tactical starting point for the whole family.
The next step up the ladder is the remotely piloted vehicle, the RPV. And this is a huge strategic leap forward. These things are bigger, they fly higher, and they can stay up for way longer. The key difference? They can fly a pre-programmed mission, but a pilot on the ground can jump in and take over at any time. This really opened the door to missions beyond the horizon.
And that brings us to the modern UAV, the real game changer of the group. These are the most versatile by far. We're talking about fully autonomous missions, flying way beyond anyone's line of sight. They use satellite links to beam real-time video and data back to base from literally anywhere on the globe.
And you can really see that whole evolution laid out right here. Just look at the progression. The size gets bigger, the control goes from simple line of sight to fully autonomous satellite links, and the endurance, well, it jumps from just a few minutes to potentially months. And of course, the capabilities expand like crazy, from just basic flight to carrying all sorts of complex tools for real-time intelligence gathering.
So we know what they are, but what do they do? This next section is all about their functions and payloads. You can think of it as the what and the with what.
Their job list is incredibly diverse. They're the tireless eyes in the sky, perfect for reconnaissance and finding targets. They can guide artillery fire with absolute pinpoint accuracy. And then, after a strike, they're the first ones in to do what's called post-strike damage assessment, basically to confirm whether the job got done.
Now, to do all that stuff, UAVs need the right tools in their toolkit, what we call payloads. This could be high-def cameras for visual intel, electronic warfare packages to jam or listen in on enemy signals, laser designators to paint a target for a missile, or even something called synthetic aperture radar, which lets them see straight through clouds or complete darkness.
Okay, let's zoom out a bit and look at the bigger picture. A UAV system is way more than just the airplane. We're about to dissect the complete anatomy. Now pay close attention here because this configuration is a really key concept.
The whole system really boils down to 4 core parts. First, right at the center of everything, you have the aerial vehicle itself, the UAV. That's the part that flies.
Next, tucked inside that vehicle, you've got the sensor or the payload. And this isn't just extra weight, it's the entire purpose of the mission. It's the eyes, the ears. It's the whole reason that UAV is up there in the first place.
Then, back on the ground, you have 2 essential elements. There's the ground control station, or GCS. You can just think of this as the remote cockpit. And then you have the launch and recovery station, the LRS, which handles the takeoff and landing.
And finally, the piece that connects the ground to the air, the data link. This is a two-way communication highway, and it's basically the nervous system that holds the entire operation together, sending commands up and data back down.
Okay, now that we've got the components down, let's talk about how these systems are actually used out in the field. This section covers the 3 main ways they're put to work, what we call operational employment modes.
First up, you have the mission UAV. This is the star of the show, the workhorse of the operation.
It's the main aircraft that gets sent out to do the actual surveillance or combat job, either flying a route it already knows or being piloted manually from the GCS.
But what happens if that mission UAV flies so far away that its signal can't make it back to base? That's where the relay UAV comes in. It basically acts as a middleman. It stays behind in friendly airspace, catches that weak signal from the mission UAV, and bounces it back to the ground control station. It's like a giant signal booster in the sky.
And finally, you've got the highest risk, highest reward strategy of them all, penetration mode. This is a silent run deep into enemy territory, completely cut off from all radio contact. It can't send anything back live, so every piece of data is recorded right there on board. And that's the massive gamble. If that UAV gets shot down, all of that priceless intelligence is lost with it. So, we've covered the fundamentals. Now let's look at some of the really advanced tools of the trade. These are the specialized eyes that give UAVs some truly extraordinary capabilities.
Yeah, beyond just standard cameras, UAVs can carry some seriously high-tech sensors. We're talking about things like acoustic systems that can pinpoint where gunfire is coming from miles away. Thermal imagers and FLIR let them see heat signatures in total darkness. And advanced DSM payloads can do electronic surveillance. Basically, they can listen in on enemy communication.
All right, let's do a quick flyby of the key takeaways. We saw how these things evolved from simple drones to super smart UAVs. We broke down the whole system into its four main parts: the vehicle, its sensor, the ground control station, and the launch and recovery station. And we looked at the three main ways they're used: as a primary mission UAV, a helpful relay, or on a high-stakes penetration run.
So, I'll leave you with this final question to chew on. Think about that penetration mode we just talked about. Why on earth would a commander choose to send a UAV on a mission like that? They know they could lose not just a multi-million-dollar aircraft, but all the critical intelligence it gathered. What kind of target could possibly be worth that kind of all-or-nothing gamble?